That brings us to our last talk for the day. And if you are a regular attender of the colloquiums, you'll know that it's normally, or it used to be, a SNOMED CT presentation. The last couple of years, we didn't have that talk. And you know what? People ran away before we even served the wine. So we decided to bring SNOMED back. So welcome to somebody who needs no introduction. John, over to you.
Wouldn't want to break tradition. Hi, my name's John Grimes. I work in the Health Data Semantics and Interoperability work group here at the EHRC. I'd just like to start off by saying a big thank you to all the other presenters. I've really enjoyed the talks today, and I think it's really been demonstrative of the level of talent and expertise we have here in the centre. So it probably won't be news to anybody within this room that this is not just a SNOMED CT concept. SNOMED CT is actually something that can be linked to a really rich ontology that has been curated by hundreds of clinicians over decades, actually. And these are additional features that exist inside your data. So SNOMED CT is being captured all around the country, all around the world, in fact. And behind these codes are a really rich knowledge resource that is being underutilized. In many ways, SNOMED CT, for me, represents the transition of EMRs from the days of sort of administrative and financial support for health services to clinical systems having a more clinical focus and being something that clinicians use for recording clinical information and using that clinical information directly within care. So SNOMED CT being more clinically focused than something like a classification like ICD is necessarily much more complicated. You know, there's an order of magnitude more concepts in the terminology for a start, and there's all these rich ontological features, and that makes it potentially more challenging to use within data science, which makes it even more necessary for us to provide our data scientists with additional tools and help to harness this so that we can start to get more uptake and use of these really valuable knowledge resources within research. So one of the ways we're trying to do that here at the centre is Pathling. Pathling is a whole bunch of tools that are designed to help with the task of doing data analytics over standard forms of health data. And the aspect of that I'm going to talk about today is our terminology support and how we bring that into language libraries. So we're creating tools that can integrate with existing data analysis workflows, existing extract, transformation, and load processes within data warehouses and business intelligence environments, and providing within that tools that can interact with terminology and harmonize queries with terminology queries to bring these two sources of data together. I'm just going to run through a few concrete examples of the types of things you can do with these tools. Here we've got a data set that contains some SNOMED CT codes. For example, it might be ED encounters. And I'm just going to show you some examples of the additional information that you can bring in alongside your data if you use this tool along with a terminology server. For example, here we've got a primary diagnosis, and we can query, for example, some SNOMED CT-Attributes from these codes. Here we're querying finding site and associated morphology. And there's a snippet of Python at the bottom of this slide which shows exactly how this is being done, the types of methods that are being called to. So we're asking the terminology server to get a SNOMED attribute value for our code, and then we're also getting the display for that attribute. Here's another example where we're testing each of these codes against some sort of value set, and we can actually describe this value set in terms of criteria. So in this case, we're actually saying to the terminology server, give me the set of all codes that are either a type of mental state finding, a type of dangerous and harmful thoughts or deliberate self-harm, and while you're at it, throw in all the historical retired codes that may have been replaced there. Make that into a set of codes and then test each of my codes against it and give me a Boolean value back. And create this sort of synthetic feature. Synonyms is another one. Your terminology server already knows a whole bunch of acceptable synonyms for each term. You can bring that in alongside your data and add in additional textual descriptions that you can use to increase recall if you're doing a textual search across your data. Translation between code systems. In this case, we're translating from SNOMED to ICD using our SNOMED Starter concept map product that we also create here at the centre, which a lot of people are interested in doing when they have SNOMED CT-based data sets, but they want comparability with ICD-10-based other research. So you can use Pathling and Onto server to traverse any type of map actually, not just SNOMED to ICD. So I also just wanted to talk a little bit about some of the future work that we're doing here. One of the things that I've become interested in recently, and thanks to Norm wherever he is, but so we've talked about the ontology behind your codes as an additional feature for your data. Well, literally, we can actually create that as an additional feature in terms of something that you can feed into machine learning. So what if you could have a feature encoder that can take a column of SNOMED CT codes and create a sparse vector that contains whatever you ask it for, actually. It could be subsumption hierarchy, it could be properties that you're interested in, and actually expand that out from being a flat code into being a whole bunch of different features about that code from the ontology. And you can then feed that into your model training. So your model now potentially has the ability to learn associations with higher level concepts within the vocabulary or attributes such as procedure site, method, due to, active ingredient. So that's one of the things that we're currently working on. And that's pretty much it. I just want to acknowledge my colleague Piotr Sul, who's a senior engineer here at the centre who's done a lot of work on Pathling with me as well, and also Michael Lawley and Norm Good, who have been working on this feature encoding idea with me. Thank you.